Hello everybody, welcome back to the Henstitute as we take a look at a few more kinematic problems. I'm going to see if I can set up these. They're still using all the equations that we have, but they're just a little bit of a change. So the key idea here is we have the cheetah is hunting their prey. So if I imagine that the prey is, just make this something with horns here, and the prey is just going to be moving at a nice constant velocity along here. So it's moving at 9 meters per second, and it does that for 3 seconds. So we've got a time, and we've got, this is actually going to be its average velocity, or you could actually say it's also its initial velocity, or you could say it's its final velocity, because all of those are the same if you're moving at constant velocity. The cheetah, however, and I'm doing really bad pictures here, so here's my cheetah, put a couple of ears on it. So the cheetah is actually going to start with an initial velocity of 0, and then they're going to chase after. I'm just going to put them sideways with this, so they're going to chase after the prey. And the idea is they're going to cover the same displacement. So they're going this displacement, this x for the cheetah is the same as the x for the prey. Put a C and a P on there. And they're going to do it in the same time, because in other words, at time 0, they were side by side, and then sometime later, 3 seconds later, the cheetah is caught up. So the key idea here is the displacement of the prey is going to equal the displacement of the cheetah. Well, it looks like I don't really have much, except that I have time down here for the cheetah of 3 seconds, and I have 0. What happens to most people is they want to say that the cheetah is going 9 meters per second, the speed of the prey, when it catches it. That is incorrect. That is impossible. If you are starting from rest and you chase after somebody that goes running by, if you only match their speed, they're already past you. You are never going to catch them. So if the cheetah only runs at 9 meters per second, it's never going to actually catch the prey. It needs to be going faster, but I don't know the final velocity of the cheetah. So that is the question mark. I'm looking for an equation that doesn't have that in it. So to find the acceleration, I need something that's going to have VI, T, X, and A, because I'm after acceleration for the cheetah. Problem is I don't know X right now, but here this little bit is going to help us, because for the prey, since they're moving at a constant velocity, I can actually find their X by just using the fact that it'd be average velocity for the prey multiplied by time. That would be my displacement for the prey, but here's the cool part. It's also the displacement for the cheetah. So this has like an initial part. We have to take 9 meters per second, multiply by 3 seconds, to get that the cheetah is going to go 27 meters. So the cheetah has to catch this prey in 27 meters. That's the displacement here. It's also the displacement up here. Now I can actually solve it. I need something that has all these things that doesn't have VF. The equation we have, this is going to be weird that I'm going to use this one, but it's the one that has X equal to VI multiplied by T plus 1/2 A T squared. It's weird to actually solve it for A, but here's an extra little bit. Since the initial velocity of the cheetah is 0, that means this part is actually going to be 0. 0 times 3 is going to be 0, even though I add it to something. So I usually just get rid of this part, and I can just say that the X of the cheetah is going to equal 1/2 the acceleration multiplied by time squared. So now I can actually find acceleration. I can multiply by 2 and divide by t squared. If you want to find it directly as a separate equation, you would actually end up with this. It'd be 2x divided by t squared. This only works, however, don't add this to your equation card, except if you want to say that it's only working when the initial velocity is 0. We now know the displacement of the cheetah, we know the time of the cheetah because they catch them in the same time. We should be able to find their acceleration. Hope that helped.